will begin shortly. Please remain.
Okay. So guys, in the last session, I hope you guys have worked on recursions and how to find factorial of numbers, right? Perfect. So in today's session, let us discuss a program that is nothing but strong number. How do you check whether a number is a strong number or not? Okay. So let us start with a simple program. Yeah, perfect. Let me take. So what is the program that we're going to work today? Yes, to check whether a number is a strong number or not. This is my question. Okay, it's a quite important TCS question. So now, first of all, before writing a program, you should first know what do you mean by a strong number. That is quite important for us to understand. If you first know what is a strong number, then you can do everything. It is nothing difficult. Yesterday we guys discussed about factorial, right? I hope you guys are aware of factorial now. What is a factorial and how do you write a program to find factorial of a number? Okay? Yes, using a recursive logic. Perfect. So today let us find out how do you check whether a number is a strong number or not. So let me explain you with the simple logic. It's very easy, trust me. Thank you guys. Throat is fine. Sorry. Okay. Perfect. Okay, so when do you say a number is a strong number? Simple. Now let me take some number, okay? Let me take some number, for example, 21. Is 21 a strong number? How do I check whether 21 is a strong number? Very simple. Do you know what you have to do is, you have to extract each and every digit. You have to extract each and every digit. For example, look here. I take the first digit 2. You need to find factorial of 2 and you need to add it with the factorial of the another digit. Okay. So that is nothing but 2 factorial plus 1 factorial. Got it? So now what is 2 factorial? Obviously 2 factorial is 2. And what is 1 factorial? 1 factorial is nothing but 1. So 2 plus 1 gives you 3. So guys, now after doing this, what is my original number? 21. Is my original number equal to this newly generated number? Is my original number equal to the newly generated number? No. Since my original number is not equal to the newly generated number, so obviously here what I say is 21 is not a strong number. 21 is not a strong number. So when do you say when do you say a number is a strong number? Very simple. Now let me take one more example, okay? So let me take another example, a very simple example indeed. Let me take 145. Okay, so if I take 145, come on, tell me guys, what is my process? I have to take the individual digits and find the summation of the factorials. I have to take the individual digits like 1, okay, summation of their individual digits factorials, okay. So that is nothing but I just have to do 1 factorial plus 4 factorial plus 5 factorial. Got it? So now tell me, what is 1 factorial? It is nothing but 1. So what is 4 factorial? Quickly. What is 4 factorial? 1? Yeah, perfect. 24. Very good. Next, what is 5 factorial? It is 120. So if I do a summation of all these three numbers, 144 plus 1, that is nothing but 145. So what is the original number that was given? The original number that was given is 145. So 145, the original number, is equal to the 145 even after doing this process. So now I say 145 is a strong number. So first of all, you should know when do you say a number is strong number. If you know when do you say a number is strong number, then it becomes easy for us to write the logic. I hope you got it now. I hope everyone got it. When do you say a number is a strong number? Please never forget this, okay? Yeah, don't forget this. It is very simple and easy. Done? Perfect. So how do I write a program to perform this? Oh my God, that's amazing. It's a very easy process. It's not at all a difficult job, okay? First, how many containers do you need? First of all, I need how many inputs, guys? First of all, how many inputs? No, 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 no. If it is not, if it is greater, we don't consider it as a strong number. We consider it as a strong number only when it is equal. Okay, if it is equal, we consider it as a strong number. Understood? You say it as a strong number only if it is equal to the original. If it is greater than the original, you don't call it as a strong number. Got it? Perfect. So now, how do I do it? Very simple. Very simple. Before that, how many inputs, guys? Step 1. How many inputs? Obviously, only one input. How many inputs? Obviously, it is one input. Okay. And now here, if you understand, what is that? Assume that I am storing the input in a container called as number. Assume that I am storing the input inside a container called as a number. Let me say it is 145. Got it? Perfect. So now what is that I need to do? I need to check whether the number is a strong number. So now we know the process. What is the process? First, you need to extract every digit. You need to extract every digit. It is always good to extract a digit from the last. How do you extract a digit? We have seen this already in yesterday's logic of reversing a number, right? In yesterday's program, we have seen how to reverse a number. In that, we have seen the logic. You can extract the last digit in 2 steps. No, not division, guys. Don't forget. See, this is the mistake. First, you should do modulus. You need to perform modulus of 10. When I do modulus of 10, you get the last digit, that is 5. And then you should reduce the number by removing 5. Okay, first modulus and then division by 10. First modulus and then division by 10. Understood? So you'll have 2 steps. So in this process, don't you think the data inside this container will be lost? Don't you think the original data present in the container will be lost? Yes or no? Perfect. Yes, it will be lost. So to avoid that, you can create one more container called as temp. Yeah, you can create one more container called as temp and do all your activities using a temporary variable. So now therefore, yes. So what is my step 2? Step 2 is nothing but, yeah, assign the value to a temporary variable. Assign to temporary variable. Why? So that I can retain my original number. Why do I assign to temporary variable? So that I can retain my original number. I hope it is clear till here. So this is my first step. Okay, perfect. So after this, let us try to do our logic. Let us try to do our logic. So now, let me take temp. Okay. Now what is there inside a temp? Come on everyone, tell me what is there inside a temp? I have 145, right? Perfect. So first what I need to do, you need to extract a digit. So I will take a variable called as D. I will take another variable called as D. Okay. How do you extract this? I would say an instruction D equals to temporary, whatever is there in temporary, modulus of 10. So when I do this, what is there in temporary? 145. What is 145 mod 10? You get 5. So that 5 I am storing inside D. I hope you understood. Perfect. Next what you need to do? Next what you need to do? You need to find factorial of D. What I need to do? Yes, I need to find factorial of D. I hope you understood. I hope you guys understood, yes or no? Okay. Now to find factorial of D, will I write a logic over here directly? No, not required. Yesterday we have seen a method. So even today I will create one method called as fact. So can I call that method fact directly? I will create a method called as fact, and for that method I will pass D. For that method, can I pass D? So what does it return to me? It will return factorial. It will return factorial of that particular digit. Perfect. So whatever factorial I get, what should I do that particular factorial? I need to find summation. I need to find summation. So therefore, to achieve summation, what I would do, I will take one more variable called as sum. I will take one more variable called as sum, and initially I will assign my sum to 0 to avoid garbage value. Initially I will assign 0 to sum to avoid garbage value. Are you understanding? So next, what is my instruction? Now I would just say sum is equal to, can I just say sum, that is whatever data present in sum, plus factorial of the digit, plus factorial of the digit. Can I do this? Can I do this? Sum is equal to sum plus fact of D. So as soon as I do this, now tell me what is D5? Come on everyone, what is D5? What is fact of 5? Fact of 5 will be 120. What is there inside sum? 0. What is 0 plus 120? It is 120. Where is it assigned? Inside the container sum. So what is there inside the container sum now? It is 120. Perfect. Perfect. Beautiful. So after this, I need to perform an update. What is my update? I need to reduce my number. That is whatever number I have in temporary, I need to reduce it. So how do I reduce it? I just say temp is equal to temp divided by 10. Temp equals to temp divided by 10. As soon as I say temp equals to temp divided by 10, you tell me what will happen, guys. What is there inside a temp? 145. So when I say 145 divided by 10, so what will you get? You get 14. Guys, 145 divided by 10 is 14. So temp becomes 14. So temp becomes 14. So completes my one cycle. This completes my one cycle. I hope you understood. Now, should I repeat this entire steps? Should I repeat all these steps? Yes. So let me try to repeat this. So again, I would say D is equal to temp percentile 10. So what is temp percentile 10? What is there inside a temp now? 14. What is 14 modulus 10? What is 14 modulus 10? 4. So where am I storing 4 now? Where am I storing 4 now? Inside D. So what is there inside D now? Sorry. What is there inside D now? 4. Got it? Perfect. What is my next instruction? What is my next instruction? Sum is equal to sum plus fact of D. Fact of D. What is there inside D? What is there inside D? It is 4. So what is fact of 4? Fact of 4 gives you what? 24. Got it? Now what is there inside sum? What is there inside sum? 120. So what is 120 plus 24? What is 120 plus 24? I get 144. Where are you storing 144? Inside the variable sum. So now sum becomes 144. Sum becomes 144. Got it? 120 plus 24 gives you 144. I'm storing 144 inside the variable sum. Perfect. After this, what am I doing? What is my third instruction? My third instruction is temp equals to temp divided by 10. Got it? So when I say temp equals to 10 divided by 10, my update. What is my update? 14 divided by 10. What is 14 divided by 10? 1. So I am storing 1 inside a temp. So what does temp become now? What does temp become now? It becomes 1. Got it? Now should I repeat all these steps again? Should I repeat all these steps again? Yes, I should repeat all the steps again. So now what will I do here? D equals to temp modulus 10. So when I say temp modulus 10, what is there inside temp? 1. So what is 1 modulus 10? What is 1 modulus 10? Obviously 1 modulus 10 is nothing but 1. So here inside a D, what you have now? Inside a D, I will have 1. Okay, perfect. Later, next step. What is my next step? Very simple. I just say sum equals to sum plus fact. Sum equals to sum plus fact of D. So now tell me what is there inside a D? Inside D, I have 1. So what is fact of 1? Fact of 1 is nothing but 1. What is there inside sum? 144. So 144 plus 1 gives you 145. And I am storing 145 inside sum. So inside sum I have 145. I hope you got it. Next, finally, what is my update? My update is temp equals to temp divided by 10. So what is there inside a temp, guys? It is 1. So what is 1 divided by 10? What is 1 divided by 10? 1 divided by 10 is 0. So I am storing 0 inside the variable temp. I am storing 0 inside the variable temp. Got it? So now tell me, should I continue? Should I continue? No, I should stop. When temp becomes 0, when temp becomes 0, stop. So you should stop when temp becomes 0. Perfect. So after stopping, I need to come out. After coming out, what should you do? What should you do? Check. What I should check? Whether sum is equal to the original number. I need to check whether sum is equal to the original number. So what is my original number? Where do you have it? I have my original number inside a variable called as num. So I will check whether sum is equal to num. If sum is equal to num, if this condition is true, then my number is strong. If this number is false, then I say it is not strong. I hope you got the logic. I hope you got the logic. Is it easy? Is it easy? Perfect. Any confusions here? Okay. So now let me write the code in C for this. Okay. Yeah. Just give me a minute. Not Java, in C, right? Yeah. Okay, let me take ash include, yeah, stdlib.h. Perfect. Now I need a method. I need a method for what? To find factorial of n. I hope it is done yesterday in yesterday's session. So you can just write the method int fact int n. Okay, so come on, what is that I need to do? If n equals to 1, return 1, right? Or else what I need to do? Return n into fact of n minus 1. Okay, so this is the method. This is a recursive method to find what? It is a recursive method to find what? Factorial of a given number. So my method is ready. Once my method is ready, it becomes very easy for me to write the remaining part of the code. Whatever we have done in the reversing logic, the same logic we can apply even here. So let me do it. Let me go to my main where I do my actual process. So first read the input from the command line. So to read the input from the command line, I just say int num equals to argument to integer argv of 1. Perfect. Yeah, Nisarga, I will help you out after this. Okay. Done. Next, what is that I need to do? Very simple. I will take one temp variable and I will assign num to it. And I need one sum variable, I will assign 0, and I need one variable d to store my digit. These are my variables what I require. Done. Now I will just take while. So while temp greater than 0. Okay, while temp is greater than 0, I need to do my task. What is my task? Step 1, extract a digit. So d equals to temp modulus 10. Temp modulus 10. Next, sum equals to sum plus fact of d. Okay, the digit. And then what I'm doing, update. What is my update? Temp equals to temp divided by 10. That's all. This is what I have to do. Right? Is there anything else I have to do? Nothing. So I just come out of the while loop. I just come out of while loop, end of loop, and here I put a decision. What is my decision? If sum is equal to the original number, if the sum is equal to the original number, then I say printf. What is that I need to print? It is a strong number. It is a strong number. Else, I just say, what is that I say? Printf. It is not a strong number. Got it? Let me save this as strong dot C. Okay? I don't think I have to do anything else in this particular program. Let me compile this. GCC strong.c. Done. Let me say A121. It is not a strong number. Let me say A145. It is a strong number. Perfect. Got this? Perfect. Please take down the program, guys. Take down the program quickly. I hope you understood the logic. Did you get the logic, everyone? If you have any doubts, you can ask me. Good. Sure, Angel, I will. Give me a minute, okay? Yeah, Deepa, I will explain you how to find power of a number using recursion. Don't worry. Finish, guys? Yeah, done. So let's go for the next program. There is nothing but to check whether a number is an Armstrong number. Okay? You just have to check whether a number is an Armstrong number. So first of all, what do you mean by an Armstrong number? What do you mean by an Armstrong number? So that is quite an interesting question now. What do you mean by an Armstrong number? Okay. It should be equal to the sum of, yes. You say a number is an Armstrong number if it is equal to the sum of, individual sum of to the power of the digits. Like for example, when I say, let me take a number 21. Okay, so if I take a number 21, what is my process again? What should I do? In the previous case, you took factorial of every digit. But here, I will not do factorial of every digit. Instead, I need to find power of number of digits. So first of all, I need to find out how many digits are there here. So can you tell me how many digits I have here? How many digits I have here? Yes, I have 2 digits. So what is that I need to do is, I have to perform 2 power 2 plus 1 power 2. So what is 2 raised to the power 2? You get 4 plus 1 raised to power 1 is 5, right? So, sorry, 1 raised to power 1 is 1. And what is 4 plus 1? 4 plus 1 is nothing but 5. So now I need to check, is this number equal to the original number? What is my original number? 21. Is 21 equal to 5? No. So therefore, it is not an Armstrong number. Therefore, it is not an Armstrong number. Got it? Okay. So let me take one more scenario. Let me take one more scenario. So the another scenario is nothing but, let me take the number 153. Let me take a number 153. So if I take a number 153, what is that I need to do is, you need to find, yes, first of all, how many digits you have in 153? How many digits you have in 153? Obviously, I have 3 digits. So therefore, what is that I need to do here? What is that I need to do here? Very simple. You need to find 1 raised to the power 3 plus 5 raised to the power 3 plus 3 raised to the power 3. Got it? So if I do summation of this, will I get back the original number? Let me check. So what is 1 raised to the power 3? You get 1. What is 5 raised to the power 3? So 5 raised to the power 3 is nothing but 125. And 3 raised to the power 3 is nothing but 27. So if I do this 1 plus 125 plus 27, I get the result that is nothing but 153. So is this equal to my original number? Is this equal to my original number? Yes. Since it is equal to my original number, I call 153 as an Armstrong number. What is this? It is known as an Armstrong number. Got it? Understood? So what is common? What is common from the previous program and the current program is, even in this current program, you need to extract every digit. So the concept of modulus of 10 and the concept of division by 10 remains same. The concept of modulus of 10 and division of 10 remains to be same. And how many times should you do it? I should do it until the number becomes 0. What is the only difference is, instead of factorial, you need to replace it with power. Okay? So here, First of all, you should know power of what. So you have to do extra two things. What is that extra two things is? First, I need to find number of digits in a number. I need to write a logic without using any built-in concepts. Without using any built-in concepts, I need to write a logic to find out number of digits in the number. This is my first method. So I will write a method to find the number of digits. Second one is you need to write a method to find power of a number. What is the second method? The second method is to find power of a number. Okay, so that is nothing but power of, yes, power of x comma n, where x is the base and n is the index. Is that clear? So what is the advantage of this is I can just say, for example, this one, 5 raised to power 3, I can just say power of 5 comma 3. I can use a built-in functions. I can use a built-in functions, but it is not recommended to use a built-in functions. You should always create your own functions. You should always create your own functions. That is recommended in TCS also. Okay? Got it? So what are the two extra functions that I need to do? One, function number one to find number of digits, and function number two to find power of a given number. I hope you understood. Yes. So now let us try to design a method to find number of digits. I don't think it is a tough job, right? The number, how do you find the number of digit? Very simple. You keep dividing the number by 10 until it becomes 0, and then use a counter and add 1. Let me directly go with the program. If you have a doubt, you can ask me. Okay. So let me check with the program. I will just directly go with the program. Let me create a method. Let me say int, okay, digit count. Let me call the method as digit count. Okay. And what is the input is nothing but an. So here what is that I need to do? I will take a loop while, okay, n is greater than 0. What is that I need to do? I just have to say n equals to n divided by 10. So every time I divide by 10, you need to count. So I take int c equal to 0 initially. So every time you divide it by 10, I would count. So I would say c++. And finally, let me say return c. Return c. So this is a method. What is the job of this method? To count the number of digits in the given number. Let me check. For example, let me say int number equals to 1204. So what is the number here? 1204. So how many digits I have here? I have 4 digits. So let me see the result. Int result equals to, I will call digit count. And for digit count, I will pass the number. And let me check what is my result. I will just say percentile D and let me put the result. Got it? I will save this as digit count dot C. Okay. Let me compile this GCC digit count dot C. Let me say a digit count. Are you getting 4? Are you getting 4? Perfect. So if you want, let me change this to 12. So how many digits you have in the number? 2 digits. So what is my expected result? What is my expected result? Let me have a look. My expected result is nothing but, yeah, let me just say, yay, 2. Do I get 2? Are you getting 2? Yes. Understood? Sahana, what is your doubt? Can you be specific with your doubt? So what am I doing here? What am I doing here? See, we have already used the logic. Every time you divide a number by 10, what is happening? You're removing one digit, right? Every time you're dividing a number by 10, what are you doing? For example, let me take 1204. Okay, let me take 1204. So if I take 1204, what am I doing? If, okay, this is there inside a container called as n. So I would say n equals to n divided by 10. So if I do this 1204 divided by 10, what does it become? It becomes 100. So what is now? It is 120, right? So I have taken C, okay, and I say C plus plus. Initially what was C? 0. So when I say C plus plus, what does it become? 1. So I will repeat this. I will repeat this. Okay, so I will again say n equals to n divided by 10. So what is there inside n? 120 divided by 10. So what is 120 divided by 10? 12. So n becomes 12. Now I would say C plus plus. So what does C becomes? 2. Okay, what does C become? 2. Perfect. So should I repeat this? Yes, I will repeat this. Okay, so I will again say n equals to n divided by 10. What is there inside n? It is 12. So 12 divided by 10. So what is 12 divided by 10? You get 1. So in n, I will store 1. I would again say C plus plus. So when I say C plus plus, C becomes 3. Good. So I will repeat this again. So what is my instruction? N equals to n divided by 10. So what is there inside n now? 1. What is 1 divided by 10? 0. So this becomes 0. And now I would say C plus plus. So what does C become? 4. Good. Now tell me, what is n now? What is n now? It is 0. Should I continue this? Should I continue this? Should I repeat this again? No, I stop. So now tell me, what is C? How many times did you divide successfully? 4 times. Why? Because there were 4 digits. There were 4 digits. Got it? Understood? Yeah, got it, Shubham? I hope it is clear now. So like this, using that logic, my C gives me total number of digits. C gives me total number of digits present. Perfect. So now I know how to find the number of digits. I know how to find the number of digits. So what is my next step? To find power of a number. What is my next step, guys? Perfect. My next step is nothing but to find power of a number. So power of a number, it is an easy process. What do you mean by power of a number? Now let me concentrate on power of a number. Now let me say power as 3 comma 2. When I say 3 comma 2, what do you mean by that? It is nothing but 3 raised to the power 2. Do you agree? No, 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 I don't want the result. I don't want the result. We need to understand. So 3 comma 2 is nothing but 3 raised to power 2. So when I say 3 raised to power 2, what do you mean by that? I have to multiply 3 2 times. I have to multiply 3 2 times. Do you understand that? Right? Perfect. So in case if I say power of 3 comma 4, what do you mean by that? What do you mean by that? I need to multiply 3 4 times. So this is a number to be multiplied. This is a number to be multiplied. How many times I need to multiply? 4 times. So I just have to say 3 into 3. I will store this result. I will store this result inside a container called as R. So what is there inside R? Come on, tell me. So this is my, yes. Come on, tell me, guys. So, okay, let me do it neatly. Let me do it neatly. Initially, what is there inside the R? I will say 1. Got it? So let me do it neatly from first. Okay, I would say, yes, I would say 1 into 3 for the first time. Let me say 1 into 3. Got it? So this is my first time. When I say 1 into R equals to 1 into 3, come on, concentrate everyone. What is there inside R now? 3? Am I correct? Perfect. Next, what I need to do? Next, what I need to do? I will again do the same process. I will again do the same process for the second time. What is there inside R? Come on, guys, tell me what is there inside the container R? What is there inside the container R? 3. So I equals to 3 into 3. This is the second time. So now tell me what is 3 into 3? What is 3 into 3? 9. 3 into 3 is nothing but 9. 3 into 3 is 9. So where are you storing 9? I am storing 9 inside R. Very good. Perfect. So now tell me for the third time, what am I supposed to do? I will just say R equals to. What is there inside R? What is there inside R? 9. Can I use the same thing? 9 into 3. 9 into 3. Perfect. So what is 9 into 3 now? 81. 9 into 3 is 27. Sorry. 9 into 3 is 27. So where are you storing 27? Inside R. So inside R I have 27. Perfect. Now should I do it again? Yes, because it says 4. So I will take for the fourth time R equals to, come on, what is there inside R? What is there inside R? 27. So 27 into 3. So what is 27 into 3 now? Yeah, I'm quite poor in math, so please help me out. 27 into 3, 81. Wow, is that correct? Yes. So now the final result is 81. Should I continue this further? Should I continue this further? Should I continue? So hence I would stop. So if you observe, how many times I did this? 4 times. Why did I did this 4 times? Because yes, x power n is 4. I hope you understood. So I think if you observe, can I write this as a single expression? Can I write this as a single expression? This 1, 3, 9, 27. Can I write this as R? Can I write this as R? Because every time I'm using the data present inside the container R. Yes, into 3. So can I say R equals to R into 3? Can I say R equals to R into 3? Perfect. So this I need to do how many times? This I need to do how many times? 4 times. I need to do how many times? 4 times. So can I use a loop? Can I use a loop to do it? Yes, I can easily use a loop to do it. Okay. So in general, now come on. If you have understood the formula, can you quickly tell me how do I find power of 5 comma 6? If I want to do power of 5 comma 6, can you tell me the formula? What is that I need to do? I just have to say R equals to R into 5. How many times I need to do this? How many times I need to do this? 6 times. How many times I need to do this? 6 times. I hope you understood. So in general, if I say power of x comma n, power of x comma n, can you tell me what is that I need to do? In general, if I say power of x comma n, come on, in general, what I should do? I just have to say R equals to R into, yes, R into x. R equals to R into x. How many times? N times. How many times? N times. But what is the one small condition? Initialization. R should be equal to 1 for the first time. R should be equal to 1 for the first time. So it becomes very easy for me. I hope you understood this. I hope you understood this. Yes. So I can use a simple for loop to achieve my task. So let me write a method to find the power of x comma n. Oh, why do I take Java always? Okay, just a second. No, it is always recommended not to use built-in functions because they would have specified not to use it, okay, or they will not allow you to include the package. Okay, so always be ready how to create your own methods. Why do you take the risk? Why do you take the risk? Okay, so let me create a method. Okay, wait just a second, include stdlib.h. Okay, so let me create a method int POW power of int x comma int n. Got it? So if this is the case, come on guys, tell me what is that I need to do. Int result equal to 1. I just take for, okay? Yeah, here if you want, you can take one more int I equals to 1, okay? Or you can just take a variable I equals to 1, I less than or equal to n, because n times, right? N times I less than or equal to n, I plus plus. So what is that I need to do? Result equal to result into x. That's it. Result equal to result into x. So finally I just say return result. I just say return result. I hope you got it. Yes. So now here let me take the input. Yeah, how many inputs I need? 2 inputs. I need 2 inputs. That is nothing but int x equals to argument to int argv of 1. Let me take int n equals to argument to int argv of 2. Okay, perfect. Now let me store the result. Int result equals to, I'll just call the method power x comma n. Vidyashri, I think you were not present in our previous class. Please ask me at the end, I will help you out, okay? Done. Now let me print f. Let me print the result, that's it. Done. Right? I will save this as POWER, powered.c. Now let me compile this. GCC powered.c. Okay, I already have a method called as pow. It's okay. I will take power. Power.c. Now let me just say a 2, 2. I should get 4. 2 power 2. Are you getting 4? 2 power 2 is nothing but 4. So let me try. A of 2 raised to the power 3. I should get 8. Got it? Next. 3 raised to the power 1. 3 raised to the power 1. I should get 3. 3 raised to the power 2. I should get 9. 3 raised to the power 3. 27. 3 raised to the power 4. 81. So is it working as expected, guys? Is it working as expected? Do you have any problem with the method power now? Simple method power? Easy? Okay. So once you know both the methods, once you know to create both the methods, what are the 2 methods required? Number of digits, a method to find the number of digits, and then a method to find power, right? A method to find power. Now I think I can easily write a program to check whether a number is an Armstrong number or not. I can easily write a program to check whether a number is an Armstrong number or not. Done? Okay. So shall I write the program or will you try writing a program? Do you want me to write a program or will you try writing it? The complete program for Armstrong now. Okay. You want me to write? Okay, no issues. I would write it, no worries. Okay, let me take a new program, C program for Armstrong. Okay, let me take ash include stdlib dot h. Okay, I will not rewrite, I will just copy the methods. I'll just copy the methods. Okay, the power, I'll just copy this method. So how many methods are created? I have just created two methods, that is the digit count and the power. Okay, so in my main method, I will just make my, okay, I would make my life easy now. I just take int number equals to argument to int argv of 1. Okay, and then I would take int temp equals to num and then d, okay, and then sum. I need one variable sum equal to 0. Both are fine, Akash. Even recursion, if you give me some time after this, if you want, I will also give you the recursion logic to find power of a number. Even that is very easy, okay? Done? Okay, just have a look here now. So what is that I need to do? I just take while, okay? While, what is that I need to do? Temp. While temp is greater than 0. So first, what is my first step? You need to extract a digit. So D equals to temp modulus of 10. So this is used to extract a digit. Now how do you find sum? Sum is equal to sum plus. I just have to find, okay? You can also do, you can easily do one more variable. I can just take int number of digits or digit count equals to, you can find out the digit count. What is the method name? Digit count, right? digit, digit count. And here I will pass the number num. Done? So here I just have to find the sum of POWR, power of the digit D, where D is my X. D is my X. So how many times I need to multiply? Obviously, that is equal to the number of digits present in the number, which is nothing but the digit count, DC. Got it? And then you need to update. So I just say temp equals to temp divided by 10. So this is my update. That's it. So once this is done, I just come out, I put a condition. What is my condition? I just check if the original number is equal to sum. If the original number equal to sum, then I just say print f. What is that I need to say? That it is Armstrong. Okay? Or whatever is put in the requirement, you just have to do that. Else, I just say printf, printf. What do I say here? Not Armstrong. That's it. Got it? So let me just save this as Armstrong.c GCC Armstrong.c successful. I just say A 121. Obviously, it is not an Armstrong number, right? Obviously, it is not an Armstrong number. Next, let me give another number, A 153. 153 is an Armstrong number. 153 is an Armstrong number. Got it? If there's one more Armstrong number, like for example 371. If you want, you can try it. 371 is also an Armstrong number. Good. You give any other number, like for example 256. Is it an Armstrong number? No. Got it? Come on, take down the program, guys. Take down the program quickly. Is it done, guys? Okay. So one more quite interesting. Many were also asking. Therefore, I will try to help you with that. That is nothing but the same thing method which I did. Power of a number using recursion. Power of a number using recursion. So what is this power of a number using recursion? How do I do it? Very simple. So to find power of a number using recursion, guys, first you need to identify. See, whenever you follow recursion, you need to come across with two things. What is that? First, the stopping condition. That is nothing but the base case. Okay. And the second one is a statement to be executed repeatedly. A statement to be executed repeatedly. Understood? So this is what you need to do. So if you observe, when I say power of a number, for example, when I say 3 comma 3, that is nothing but 3 raised to the power 3. If you observe, what is that I need to do repeatedly is, first, can I take, okay, this is the number to be multiplied. Okay, let me take, it's a confusing value. So let me take 3 comma 4. Let me take 3 comma 4. Power of 3 comma 4. Okay. Can you tell me the number which has to be multiplied? Can you tell me the number which has to be multiplied? That is nothing but the base, 3. How many times I need to multiply? How many times I need to multiply? Yeah, I need to multiply this 4 times. Got it? So I'll just do one thing, okay? What is that I will do is, I will take this number 3, okay? And I will say 3 into 3. Okay? 3 into 3. Do I get some result? Do I get some result? 9. Yes. Understand my process. Okay? Next, can I say again 9 into 3? Can I say again 9 into 3? Yes. Okay. Perfect. So you get 27. So can I again say 27 into 3? Can I say 27 into 3? Yes. So that is nothing but, yeah. Yes. So what is 27 in 81? So finally what I should say into, yeah. Got it? If you observe 1, 2, 3, 4 times over. I hope it is done 4 times. How many times it is done? And finally for the last time, can I say 81 into 1? Can I say 81 into 1? Yeah, sure, Sachin, I will. Don't worry. Okay. So why? Yeah, good question. Kritika Sharma is asking me why 81 into 1. I will tell you. But first tell me, if I do 81 into 1, do I have any problem is my question. Do I have any problem? No, right? You don't have any problem, right? So that is my stopping place. I'm using this to stop my situation. That's it. So look what I'm gonna do here, okay? Look what I'm gonna do here. For the first time when I do it, can I consider this 4? Okay? And when I repeat this again, can I say 4 minus 1? So what is 4 minus 1? 3. Got it? Understood? Perfect. And when I do this again, can I say 3 minus 1? That is 2. Got it? And for the final time when I'm doing here, can I say 2 minus 1? That is nothing but 1. Are you understanding? Yes? So what am I trying to say here is, I will do it in a better way now. Observe carefully. Can I take this 4 present in a variable called as n? Can I take 4 inside a container called as n. Okay, so this I'm doing for the first time. Every time I do this multiplication, assuming the activity is done once, can I reduce it? So how many times I need to multiply 3? Come on, tell me how many times I need to multiply 3? I need to multiply 3 how many times? 4 times. So assume that I had done it once over here. So can I say n minus 1? So can I say n minus 1? For this, yes. So now can I say it is 3? Perfect. Perfect. So I am again doing the activity. So can I say here n minus 1 again? Can I say n minus 1 again? So what does 3 becomes now? 2. So I'm trying to do it again over here. So I'll say n minus 1. So when I say n minus 1 over here, what does it become? It just becomes 1. Got it? And when I try to do it here again, so what is n minus 1? It becomes 0. I hope you understood. I hope you understood. So now tell me how many times I should multiply, how many times I should keep multiplying, how many times I should keep multiplying until my n reaches 0. Until my n reaches 0. Every time you multiply, what is the update I'm giving? N minus 1. What is the update I'm giving? N minus 1. Got it? Yeah. Perfect. Perfect. Okay? And yes. And then what am I doing here? How many times I'm doing this? I'm doing this until n becomes 0. I'm doing this until my n becomes 0. As soon as my n becomes 0, as soon as my n becomes 0, I just have to multiply it with 1 and stop it. I just have to multiply with 1 and stop it. Do you agree? So this becomes my stopping case. So in all the remaining case, x. What is 3? 3 is nothing but x. What is 3? 3 is nothing but x. Got it? Yes or no? Yeah. So let me write this in a more beautiful way. Let me write this in a more beautiful way for you to understand it. Okay. So look here. I would say power of 3 comma 4. So can I write this as 3 into 3 raised to the power 0? 3 into 3 raised to the power 0. Next. Can I again write this as, can I again write this as 3 into 3 raised to the power 1? Can I again write this as 3 into 3 raised to the power 2? Can I again write this as 3 into 3 raised to the power 3? Did you understand this? You can either write it like this, or you can also go in the reverse order. What is that reverse order? 3 into 3 raised to the power 3. So what is 3 into 3 raised to the power 3? That is nothing but 3 raised to the power 4. Now, okay? Now, come on, listen. Yeah, let me complete this first, okay? So 3 into 3 raised to the power 3 is nothing but 3 raised to the power 4. Good. Now, how do you get 3 raised to the power 3? Very simple. Can I again say 3 into 3 raised to the power 2? 3 into 3 raised to the power 2. Can I further write this as 3 into 3 raised to the power 1? Can I further write this as 3 into 3 raised to the power 0? Can I further write this as 3 into 3 raised to the power 0? So what is 3 into 3 raised to the power 0? Guys, please tell me what is 3 into 3 raised to the power 0? What is 3 raised to the power 0? 3 raised to the power 0. 3 raised to the power 0 is 1. So I hope you understood now why I took 1 at the last. I hope you understood why I took 1 at the last. Got it? Understood? Understood this? So now you can go in the recursive way. Now can I go in the reverse order? What is 3 into 3 raised to the power 1? 3. So substitute this over here. Substitute this over here. 3. What is 3 into 3? 9. So substitute here. You get 9. What is 3 into 9? 27. You get 27. So this I will substitute here. 27. So what is 3 into 27? 81. So did you get the final result? Did you get the final result? Yes or no? So what am I doing here? What am I doing here? Very simple. Convert this into a simple expression. Convert this into a simple expression. Can I write this as 3 into power of 3 comma 3? Power of 3 comma 4. Can I write power of 3 comma 4 as 3 into power of 3 comma 3? Yes. So the power of 3 comma 3 can be written as 3 into power of 3 comma 2. Now power of 3 comma 2 can be written as 3 into power of 3 comma 1. Then power of 3 comma 1 can be written as 3 into, power of 3 comma 1 can be written as 3 into power of 3 comma 0. Understood? Understood? So I need to perform, so to find power of 3 comma 4, I need to multiply 3. Every time recursively with the same method. But what is happening over here? Your n is equal to 4. So here, what is n? You get that is nothing but 4 minus 1, 3. So here, what is it? 3 minus 1, 2. So here it is nothing but 2 minus 1. That is 1. So here it is 1 minus 1. So can I write the general formula as? Power of x comma n. Power of x comma n can be written as x into power of x comma n minus 1. Can I write it like this? Yes or no? How many times I need to do this? I need to do until n becomes 1. Sorry. I need to do this until n becomes 0. So now when n is 0, what is power of 3 comma 0? What is anything raised to 0? 1. So when n is 0, what should I return? 1. When n is not 0, what should I return? X into power of x comma n minus 1. So that is my method. That's it. So look here. Let me take, not Java, sorry. Recursion. Let me take C to find power using recursion as include stdlib.h. Okay. So let me take int POWER power of x comma n. I'm using the logic, recursion logic. If n equals to 0, I just say return 1. Okay, if not, I just say return x into power of x comma n minus 1. That's it. This is my recursive method. To find. Power of a number. So let me take let me take two values, int x equals to argument to int argv of 1. Okay, next int n equals to argument to int argv of 2. Okay, now let me take int result equals to power of x comma n, and let me print it printf printf. Let me say percentile d result. Got it? Okay, let me save this as POWER power 2 dot c GCC power 2 dot c. What happened? Yeah, it's okay. Warning. Now let me say a of 2 2. So what is the result I get? I should get 4. Are you getting 4? Yes. Let me say a of 2 3 8. Am I getting it correctly? A of 3 0. Are you getting 1? Prajwal, you asked me what will happen if n is 0. So a of 3 0. Are you getting 1? Yes. A of 3 raised to power 1. A of 3 raised to power 2. Got it? A of 3 raised to power 3. A of 3 raised to power 4. Perfect. So it's working. Got it? I hope you got the concept. Please take down this program. Method. A recursive method to find the power. I hope you got the logic also. I hope you guys got the logic also. Done. Okay, guys, thank you so much. It was nice. I hope you guys had a good session. Tomorrow we'll discuss about series. Okay? Tomorrow session we'll discuss about some series related program. Okay, mixture of two series. How do you find the nth? How do you find nth number in a series? Done? Okay, yeah, sure. I'll show you the main method. No, this much is not enough. Okay, these are few of the programs that you can do it. Okay, there are many programs that you can learn. Okay, so in tomorrow's session, I will also give you a link, a website where you can refer more programs for TCS related pattern. Okay. Yes, writing program in C is allowed in NQT. Yeah. For command line input in Python, there is one package that you need to import. I will tell you tomorrow. Tomorrow, if you want Java and Python, how do you use command line arguments? I'll let you know in tomorrow's session, last session. Okay. Vaishnavi, okay. Did you understand, Vaishnavi? How do you find the power using recursion? Yeah. See, these are the simple programs that you get. Okay. Please use a lot of websites are there like Hackathon, lot of this. You know, the best way to become good in programming. See, in 3 days, 4 days, you cannot learn all the programs, okay? Cultivate a habit in such a way that at least 1 or 2 programs you solve every day. Every day, 1 or 2 programs you solve by taking a problem statement from the net. Only then you can become very good in programming. Got it? Just by learning 10, 20 programs is not enough. If they did not specify command line arguments, then you can use a normal dynamic input. Okay? Yeah, sure, Meghala. Look here. See, the meaning of recursion. I mean, Meghala, do you want me to trace the program or you want me to explain the logic? You want me to trace the program or explain the logic? Program. Okay. See here. Okay. Just observe, concentrate carefully. Okay. Now, assume this is my method, right? This is my method, right? I will say, for example, now, power of 3 comma or 2 comma 3. Let me take for a sample one. 2 comma 3. Okay. Okay. When I say power of 2 comma 3, it will go here. What is my first condition? N equal to 0. So this is n, right? This is n. This is x and this is n. So now tell me, okay, so since you're calling it for the first time, since you're calling this for the first time, what will happen? Yeah. See, I will put in the form of boxes and I will explain so that it will be more easy. Okay. Value of x. What is x? 2. Value of n. What is n? 3. What is the condition here? Condition n. 3 equal to 0. Now 3 equal to 0, true or false? 3 equal to 0, true or false? This is false, right? If this is false, I will go to the next statement. What is the next statement? Return x. What is there in x? 2. 2 into, I hope you are understanding. Wait. 2 into power of x. What is there in x? 2, comma, n minus 1. What is n minus 1? 3 minus 1. So 2. So am I calling the method again? Since I'm calling the method again the method of frame will be created. Again a frame will be created. So now x, what is the value for x? What are you passing? 2. What is the value for n? 2. So again check the condition. If n, that is 2 equal to 0. 2 equal to 0, true or false? It is false. Since it is false, what I'm doing? Again I will say return x. What is there in x? 2. 2 into power of x, that is 2, comma, n minus 1. What is 2 minus 1? It is 1. So I'm calling the method over here. So again a frame is created. Again a frame is created. What is x now? 2. What is n? What are you passing? 1. So here I just say if 1 equals to 0. So when I say 1 equal to 0, is the condition true or false? False. So I will again say return x into, that is 2 into power of 2 comma n minus 1. That is 1 minus 1, 0. Got it? So when I do that, I'm calling the method again. So again a frame will be created where x is, what is x you're passing? 2. What is n you're passing? 0. Got it? Now I check the condition. If 0 equal to 0. So now tell me 0 equal to 0. Is this true? 0 equal to 0. True. What you are saying now? Return 1. Return 1. So what are you returning now? 1. So 1 is returned. So in this place, 1 gets substituted. Got it? So now tell me what is 2 into 1? What is 2 into 1? 2. Do you have anything else pending in the instruction? No. So now what I will do, return 2. So this 2 is returned here. Got it? Now 2 into 2. What is 2 into 2? What is 2 into 2? Yes, others, you can run your test. Don't worry. What is 2 into 2? You get 4. So 2 into 2 is 4. So return 4. To whom will I return? To the calling method. Right? Understood. So what did I return now? 4. So now tell me what do you have here? 2 into 4. So what is 2 into 4? 8. Is that clear? So finally what are you returning? 8. So now tell me power of 2 comma 3. Is the result 8? Power of 2 comma 3. Is the result 8? This is how you need to trace it. This is how you need to trace it. You will get it easily. It's not difficult. Understood? Perfect. Okay guys, then bye-bye. Perfect. Vinodini, it's not like they will give you all the questions from one section. You can easily navigate, you can skip from one question to another question and you can get back. Is that clear? But everything will be recorded. Everything, whatever activities that you perform will be recorded. Just be careful of it. That's it. Okay? Okay, guys. Bye-bye. See you all tomorrow.